first one is just 18.
Yeah, 3 times 6, 18.
And the second, uh, 8. The second one is 12 times 8 sine 35,
Okay.
which is 55.1.
55.1.
Mm-hmm.
0.1, and that's going clockwise.
Yeah. How can you tell which direction it is? Because I don't always understand.
Clockwise is its own direction. So this is like a rocket, and
Uh-huh.
so this is the stationary things. This is like the nail, and it's gonna fly around like a firework.
Okay.
And
Um,
usually, if it's clockwise, we say minus 55.1.
I thought clockwise was positive and anti-clockwise was negative.
Usually other way around.
Oh.
They'll work out, but just so long as you use the same thing. But the convention is that anti-clockwise is positive. Okay, how about this?
So one force is just 10 Newton meters,
Mm-hmm.
and the other one, I'm not sure how to do the second one.
Just ignore the first one. So
Hmm?
how did you do it a second ago? What if there was none of that? What if it
But
was just
um,
what if I copy and paste this one? Just this one here.
which one?
This one up here.
Yeah. Is it?
So a second ago you said it was 12 times 8 sine 35.
Yeah. But there isn't a right angle for this one. So,
You can imagine there is
oh, right.
something like that.
So that would just be 2 sine 50
2,
times 8.
2 sine 50 times 8.
Yeah. Anti-clockwise.
Oops. Anti-clockwise, yep. What do
Yeah.
you get?
This one's clockwise.
Okay. And so, what do you get?
Oh, 12.3.
What do you do with those?
Oh, don't you have to minus one from the other?
Which one from which?
You minus the clockwise one from the anti-clockwise one.
Yes, so clockwise minus anti-clockwise plus. What do you get?
2.3.
2.3 Newton moments or something?
Isn't it Newton meters?
Newton meters.
Yeah.
Let's see. Magnitude of that one is 10. Magnitude of that is 12.3. Find the moment of each force. Oh, they just wanted them. Okay, but
Okay.
yeah, it's a lot more useful to have that one. And the fact that it is 2.3 and a positive answer tells you that it's going anti-clockwise.
Anti-clockwise.
Any questions there?
No. I can do the easy ones, but when it gets harder, yeah, like the
Okay. How about this one?
um So if the moment about A is twice the moment about B, then that means like it's like the distance between A and C is like double the distance between A and B. Oh,
Okay.
it's actually a really easy question. Isn't AC just 0.4? And then BC is 0.2.
Zero. So which one is AC?
AC is 0.4 because it's longer.
0.4. There you go.
Should be.
4 marks. Oh, there you go.
Why is that 4 marks?
What do you give yourself for that one?
Yeah, I understand like this part of it, but
Okay. Resultant moments. Let's try it. So this is what we
oh,
just did.
this is when you like add them or subtract them.
Yep.
Okay.
We'll try one.
Okay. So there's one force that's 5 times 3, which is 15 Newton meters. And then there's one that's 4 times 1, and then there's 3 times 1 as well. Oh, I didn't write the directions. But the one that's 15 is clockwise,
And how can you represent clockwise?
minus 15. And then it's minus 4 as well.
And so P is the pivot. That's our rocket. So that is what direction?
That's anti-clockwise. Okay.
How do you represent it?
Positive. And the 3 is positive as well.
Mm-hmm.
The anti-clockwise. So that would be minus 8.
Minus 8. And you don't need to say clockwise or anti-clockwise. If it's minus, it's implied that it is clockwise. Okay, calculate the resultant moment about P. 8 Newton meters clockwise.
Okay, got positive 8.
So they did positive
They
8,
did
but they stipulated clockwise.
okay.
Minus 8 implies 8 clockwise. I suppose couldn't hurt to say which direction.
So there's one that's 4 times 3 sine 40, and it's anti-clockwise, so it's positive. Should I work out what it is?
You can do it all in one go at the end.
7.71. And then there's one 18. I think it's anti-clockwise. 6 times 3. And then
How do we represent anti-clockwise?
positive. The last one just be 5 times 4 sine 80.
Oops. 5 times 4 sine 80.
And that's clockwise, so that's negative.
Okay.
And that's 19.7.
Resultant.
Is it okay to round these or not?
It's usually not. It'd be better to not.
Okay. .02.
So 6.02, 3 sig fig. And if we were to...
It's anti-clockwise, I think. Yeah.
Yeah, if it's plus, that'll be anti-clockwise. We'll just write it into the case. And I was gonna, so you picked up on it. So if you had not rounded it, 7, is it 7.71 plus 1.8?
It's 6.01.
Yeah, and so that's why you don't round it too early. 6.02, great. Unrounded values. Oh, good. Okay. How about this?
So the first one is 7 times. Would it be 8 tan 25? Or is that wrong?
I think you should say sine 25.
It's sine.
Is
Oh,
it? Opposite over
wait, so does it
hypotenuse.
not? Oh, wait, that's not the that is the hypotenuse. Okay, never mind. And then the second one is just 4 times 8 sine 35.
Okay.
So is it just usually like always sine?
I believe so.
42 Newton meters.
And okay. Whoops.
Forgot the directions, but
No. Which is
it's because of directions, I think. Because this one that's 7 is clockwise,
how do
and
you
then the
represent
one
that?
4 is anti-clockwise. So the 7 one should be negative. Which gives you minus 5.31. Or 5.31 clockwise, yeah.
Yep, there you go. So definitely you always need to put in the sign. And you can see that they're acting against each other, going towards each other.
Yeah.
Any questions? That's what it looks like. Any questions about that?
No.
Great. Okay, this is more like it. How about this?
Okay. So 12x, which is clockwise, so minus 12x. Wait, why is it minus 6 times 2x? Oh, I did the other one, the one that's 12 newtons and then x meters, because that's 12x as well.
Oh. Okay, so
But
minus
also
x times.
going the same direction. Wait, but that one's the one that's minus 6 times 2x. Shouldn't it be like 2x plus 3x plus x?
Sure
Because it
should.
says about p.
Sure should.
That next one's 40x plus 40x.
Okay.
And then minus 6, 36.
And is that plus or minus 40x?
Plus. And then the last one's minus 36x. Which gives you 8 Newton meters clockwise. Minus 8, basically.
What happened to x?
Oh, 8x. So 8x is equal to 12.8. So this is equal to 1.6 meters.
X equals 1.6 meters. 1.6 meters. Great. Is this worth doing?
I don't know.
It probably is.
So the first one's going to be 130. Wait, no. 120 sine 130. Is that right? I don't know if that's right.
Times, what was it? 120?
Sine 130. Is that correct?
Where are for this one, is it?
Yeah.
120 is the distance.
Yeah. And then sine 130 is the angle.
What is the force?
6,000
How do you use that?
times 6,000.
Times 6,000. I'm going to take a chance. Sine 50. Is that not it?
Is it? Oh, okay. Because I thought the distance was 120 times sine 130. I know why. Because I'm not sure. Because wouldn't like the 120 not be the perpendicular distance?
From the dock.
Isn't it? It says from P.
Yeah. So this from P. So that's 120. And so you need this component here.
Yeah.
So maybe you're right. Let's take a look. If that was that. Alright, 130. What's...
I don't know if it's right.
And with or without 6,000?
With.
So it definitely has to have 6,000.
Yeah, because that's the force. You need that, obviously.
Mm-hmm.
And then, okay, there's another force that's 4,000 times 30. Yeah, 4,000 times 30. Wait, the first force is clockwise, I think.
Yeah. So
It's negative.
Okay.
And then the second one is also clockwise. The one that's 4,000. I'm not sure because it's like horizontal.
Okay. And it's 4,000 times what, sorry?
Times 30.
That's right. Anything else?
And then the last one is anti-clockwise, 5,000 times 240.
Mm-hmm. Before we put stuff into calculator. So we wanted this x.
Yeah.
How do you get it? So this is 50, so that must be 50.
1,000 sine 50.
So sine 50 is opposite over hypotenuse, so x over 6,000.
Mm-hmm.
So x over 6,000.
But I thought you couldn't use that 6,000 as a value.
Why not?
Because it's not a distance, it's a force.
In vectors, force is represented as distance.
Oh, so you can use it as a value.
Like you must use it as a value.
Okay.
Otherwise, this would be
When we
1.
did it in school, we were told we couldn't use like force because like it's not a distance. I know why.
Like, I suppose it depends on the context, but on a
like when we were trying to figure out like the perpendicular distance, you can't use like if you draw a triangle like that, you can't use the force value as a like in a trig thing.
like
Because it's not a distance, it's like the force. I don't know how to explain it, but like
So
I
if
know
you
our teacher told us we weren't allowed to do that.
so you see this 5,000 force.
Yeah,
If I was to turn that going this way, it would be a bit longer than the 4,000 one, and
yeah,
that's because force is represented as distance.
okay.
It's
So
represented as
you
length.
can use it then.
I mean, you must use it. There's no,
Okay,
there's
that
nothing else.
makes sense. So it's 6,000 sine 50 and not sine 130.
Yeah.
Okay. And then now got to figure out.
So I'll let you put all those in. See what you get.
Um, 528,448. It's positive, so anti-clockwise. That looks wrong.
Feels wrong.
That, huh?
Feels wrong. No, it's right.
Oh, it's right.
It says anti-clockwise. Yep. Great.
Oh, yeah, it did.
Yeah. Don't overthink it. 6,000 sine 50.
Okay.
Any questions there?
Not really.
Okay.
No.
And you can always go back to first principles. That's x. If that's 50, then that must be 50. And so,
But like, why would you? I'm confused why you would want like that distance. Wouldn't you want? Isn't that not the distance that you want?
you want the perpendicular distance.
Yeah.
The perpendicular is 6,000 sine 50. So sine 50
Okay.
is opposite over
Because like
hypotenuse.
our teacher told us that to find the perpendicular distance, you should draw like a line through the fourth, and then like a line through the pivot, and then like see what the distance is or something.
So you can do that like we did it here. So we did prove that it is 6,000 sine 50, but it's never not going to be that. Or maybe I'm wrong.
But why is it not like 120? Like just 120?
What this?
Yeah.
Basically, it's a rectangle. So you see how this one was 240 times 5,000?
Yeah.
So base times height. So this one down here, 120 times x. X
Uh,
is 6,000 sine 50.
okay. That sort of makes sense.
Yay. Let's see this thing. It'll probably be okay for it. Is it worth doing?
I don't know. I'm not that good at the moment, so.
All right.
So there's one that's 25 times 4 anti-clockwise, so positive. And then there's one 3 times 2, that's clockwise, so it should be negative. And then there's 6f, which is positive as well.
What direction is it?
It's clockwise. Oh, is that? Yeah,
Well, it is clockwise.
negative. Okay, so 20 minus 6. $3.167.
I'm getting 3.5.
How did you get 3.5?
Copy paste. Unless I put it in wrong. Nope, I have an extra negative by mistake. Is that why?
5
5 times 4. There we go. shift solve. 1.5.
How did you get 1.5?
You see what I see? Did I put something else in?
Shouldn't it be equals -5? Because it says it's 5 in the clockwise direction.
Oh, very good. I was just trying to do it faster than you. Shift solve. There we
Yeah.
go. Yes. And let me just press answer. Hang on. Boom. Answer equals 19/6. Okay, so just as an exact value, just in case there was a...
You know that button on the calculator that says like S arrow D?
Mm-hmm.
You can just use that to convert like between fractions and decimals.
Oh, you can you, young lady?
Yeah. On my calculator it says F, but it's like the black next to the brackets.
X equals 2/3. Shift solve. SD.
Oh.
You
Okay,
see
now
that?
on this calculator.
It's when you're in this equation thing, it doesn't.
Oh,
But
okay.
my way around that is press answer. Yep. You cheek this man, I did. 19/6. Great. Is this worth doing?
Oh my god, I know a thing for this, but I forgot. It's like tan theta is equal to something alpha something. I don't know. Hold on, I'm gonna look it up. I know it's really messy. I can't find it. But anyway. I don't know how to do this.
I don't think we need to look it up. Just do what we were doing. The rod. 8,000 down.
Mm-hmm. But how do you know what point to take to do the moments around? Okay. So 8,000 cos theta. Wait, no, that's wrong. I don't know what the distance is. Or is it 8,000 cos theta? I don't know.
Let's see. So this is theta. This is 8,000. So that one is 8,000. So what would the hypotenuse be?
Wait, which one's 8,000? Yeah, that one's 8,000.
Mm-hmm.
So the hypotenuse would be 8,000 cos theta.
I believe, what is this side in the triangle? In relation
Oh,
to
the opposite, the sine. 8,000 sine theta.
Okay, so that there is 8,000 sine theta.
Mm-hmm.
How about this thing? And what direction is that going?
Anti-clockwise.
So that is anti-clockwise.
And then what would the distance be for the second one?
Let's see. So for this one, the distance from here to here, we could call that like D or something, and then the other would be 2D.
No, but isn't that 8,000 sine theta already?
But I think it would be... So from here to here, would it be d times that?
Maybe. Okay. I don't think you can say it's 2D because you don't know
Well,
where the force acts.
it's a uniform rod, so we say all its weight
Oh,
is in
in
the
the middle.
center.
Yeah.
Yeah.
But 8,000 is the weight, not 6,000. Oh, wait, no, it's in the middle. Never mind. Wait, so what's the distance for the 6,000 one?
It'll be double this distance, won't it?
Wait, for the first one, if the distance is 8,000 sine theta, wouldn't you need to times it by 8,000 again? Because that's the distance, and then you have to multiply by the force.
Let's see. So this.
But I don't think that's the distance because it's not perpendicular.
Let's see. So this is
The
going.
side, the side that has like the dotted line, wouldn't that be the perpendicular distance?
So that's the perpendicular distance.
Yeah.
Okay.
And that's not 1,000 sine theta.
So what is the perpendicular one?
8,000 cos theta,
So that is 8,000 cos theta.
I think. Not sure.
Yeah, because that's adjacent.
Yeah.
That is 8,000 cos theta, and then the hypotenuse would be 8,000 sine theta.
Sine theta. But the moment is 8,000 cos theta times 8,000.
So 8,000 cos theta times by 8,000.
And it's anti-clockwise.
Mm-hmm.
And then, yeah, I don't know what the distance would be for the second one.
Well, the distance for the first one is 8,000 sine theta.
No, it's 8,000 cos theta, the distance for the first.
So you're referring to perpendicular distance? To horizontal distance? Okay. So whichever way you look at it, it's going to be double, won't it?
I don't know what the second one would like the distance be. The one that's 6,000.
Won't it be double? If
Oh.
this is the midpoint?
Yeah. Yeah, maybe. So that would be 16,000 cos theta
Yep.
times 6,000.
So that is 16,000
Clockwise, that would be minus.
cos theta
Times 6,000.
times 6,000. Hold on. This angle is here. So that means this is theta. Does that change anything? Because it's like a alternate angle, Z angle.
Oh yeah, it's Z angles.
And so, does that mean it is sine? If I did that there, does that make it sine? Theta? Who knows? What do you know about these two, relationship between them?
Between what?
These two forces. The drawbridge is rising.
Oh. So the 6,000 force is bigger than the...
Yeah, so I've already done it, so I'll just do the other one is less than it.
Yeah. So then you just solve for tan theta then, right?
How do you do that?
Divide by 1,000. Everything.
Yeah.
8 Wait, 64 cos theta on one side, and then 16 times 6, 96 sine theta.
Okay. What next?
And then you could divide by 64 because 96 divided by 64 is 1.5. Or you could just divide by 64 cos theta. Both sides.
Yep.
Because then you'd have 1 and then minus 1.5 tan theta.
Let's say we divide both sides by cos theta.
Why don't you just divide by 64?
Yeah. Okay. So then we get
1
1
or
is
64
less than
minus 1.5 tan theta. Then you have to divide by minus 1.5. So you have to flip the inequality sign. And then you'd get 2/3 on the side that has 1.
You get 2/3. You divide it.
Inequality sign.
You divide it by negative. That's tan theta. And so to put that way, I'd move them. Did I do that wrong with the inequality sign? Let's see. Let's see. What did we do here?
1,000 cos theta. How? I don't know what they did.
6,000.
I don't know the length of the drawbridge. What?
So they just called it x.
Okay.
So 6,000 x sine theta.
This is how you need to draw the lines. I like drawing the lines. It helps.
Yeah. Tan theta greater than 2/3. Okay. Any questions there?
Kind of. Bit confused.
So I think it would probably help if we just said. So I thought of this thing as being x and the other.
I don't understand why the length of the drawbridge would be the perpendicular distance.
They just took that as the perpendicular.
Okay, like they just assumed that
they just kind of took that to be the perpendicular, and so they did their 6,000 that way and their 8,000 that way.
Oh, I think they might have put. Wait, did they put that pivot in a different place?
No, this is definitely the pivot.
But then that isn't the perpendicular, so. Oh, like they moved the direction of the force or something.
So imagine you said like, I'm going to take moments in this direction, something like that.
Oh, you can do that. You can change the direction.
Sure. You can say left is positive, right is negative, up is negative, down is positive.
Oh, I know you could do that, but like, you know how you drew like the red arrows and said they took the force like that way?
Yeah.
But wouldn't that be changing the direction?
It should all work out. The difference is they had to do 2 changes. We only had to do 1. I think it's the same really. We just had to change this. They had to change this and this. But I think it worked out.
I don't really get it, but it's okay.
So 6,000 times, let's say, d sine theta for the drawbridge. So they did it as a half. I think, is it more obvious if you said it's 2d sine theta?
I don't understand. Wait, what do the red arrows mean on the diagram?
That is the force that is perpendicular to the drawbridge.
Okay.
So drawbridge.
Why would you need a force that's perpendicular?
So that's essentially what we did anyway. It's always times perpendicular force. So like
it's not times perpendicular force. It's times perpendicular distance.
Same thing. We represent force as length as distance.
Oh, okay. I don't really, but
d cos theta. Let us see. So if this is theta. No, you know what? I'll let you study. They just oriented it a bit differently.
okay.
They just took moments diagonally. Yeah, I'll let you study it. We got the idea. I just don't want to get bogged down on one weird question that old bookie throws at us. Let's see. Is this one worth doing? That's not bad. How about this one?
So you have to find the moments first. So if we're taking moments about Q, then you'd have negative 2f, because it's clockwise, and then negative 10, and then plus 3 times 7. Yeah. And then you're taking moments about P. You'd have 7. And then you'd have plus 10. Minus 4f. Yeah. So then you have 2 equations. And then it says the one that's Q is like twice. So you can just do minus. You should just solve. Yeah, you just have to solve for f.
How so?
So you do like the first one, the one that's like around Q, is minus 2f plus 11. And then you know it's equal to like 2 times the second equation, which is 17 minus 4f. So you can just like equate them to each other because they're both in the same direction.
F, and then you solve from there.
Yeah, it's 4f, but
for f.
it's a bit of a weird answer, so I'm not sure if I did it right. 3.83.
Feels weird. 1 sec.
Yeah.
Minus 4. Okay. Answer 23 over 6. 23 over 6. Great. Any questions there?
No, that one was fine.
Grandest. And this one is similar to the one we did before. Is it worth doing?
Yeah. P. So, okay, so the first one would just be 120, I think. Perpendicular distance would just be 120 times 1100. And it's anti-clockwise.
Mm-hmm.
Okay, and then the second one would the second one also be 120?
Hold on. This is 1100. Yeah, that would be correct if it was like that. 1110.
Oh, so it's not.
So what? How do we deal with it if it is diagonal?
Sine 60. And then the second one would be also anti-clockwise, so it'd be plus. I think that would go anti-clockwise.
I think so.
120 times 2000 sine 45. Yeah.
Yeah.
And then you just multiply.
Or you can do part B, and I'll do this. It's quicker than me.
285. Wait, no. 284,021.
Okay. And B.
State 1 modeling. What modeling assumption is there in moments?
0, 0, 0.
Can you say like anti-clockwise is a positive direction is a modeling assumption?
No. Maybe ignore water. Not tension. What do you call it? It's like
What resistance?
water resistance. Yeah. Ignore water resistance. Just trying to think. What assumptions did we? Sure. 312. Did they do something?
Resistance due to air water is ignored.
Does it say that?
Yeah.
Resistance due to air water not. 312.
Huh? How?
So they did kilo Newton meters. So they think that's divided by 1,000.
So
Let us check. So this one here, this angle is 60. So this is 60. That's opposite.
that's why I thought it was 120, because like if you draw the lines,
Yeah.
the distance between them is 120 meters.
Right. So that's 120.
If you drew like a line in the same direction as the force and then like through the pivot.
So what do you suggest? 120.
Like one line in this, like where they are, where you don't need to draw a line there because there's already the arrow, and then like a line in the same direction but like through P, so like diagonal.
Like that.
Yeah. Yeah. Like if you look at that, the distance is 120 between them.
Right. I mean, we have 120, don't we?
No, but we did 120 times sine 60.
120 times 1,100 sine 60.
Yeah, I don't think there should be a sine 60 there.
Why not?
Because there shouldn't be one. I don't know.
Pretty sure. Okay, so if I take away sine 60, because that implies that it's perpendicular. That would be straight down. So that would be 302. No.
Maybe the second one shouldn't be sine 45 either.
I don't think so.
Nope.
372. let's see. So this is definitely, so that's opposite. This is hypotenuse. So yeah. And then so this other one is the one to look at.
Wait, so the first one is sine 60.
Yeah, it's definitely sine 60.
Okay.
Then this one, so if we were to do that, so that's 120. That's 45. Oh, they'll both be 45. So this is hypotenuse. So we
You can't
want,
say they both be 45.
so this will be 90. And so that's
Yeah.
45. That's
Oh,
45.
yeah. That's true.
So, so sine 45 and cos 45 are the same thing. We want 120 times this. This is is it is it clockwise?
I'm pretty sure they're both.
Yeah.
I don't know. The one that's at 45 degrees, I'm not sure about the direction, but I think it's anti-clockwise.
I think they're both anti-clockwise. There's a thinker. Is this answer correct? 312 to 3 sig fig anti-clockwise. So that
I mean, the second part is right.
I think their answer must not be correct. I mean, it's a very simple question.
Second part one. It's a bit weird. But sometimes, yeah, sometimes answers are wrong.
Meters, newtons. Oh. Is it
What?
20 instead of 120? It's 20 instead of 120.
What?
For the second one.
Why? Oh, because it's that side is 20. Oh, that makes sense.
Wait.
I did not know that. I don't get like these hard ones, but nope.
So we're saying, so the answer should be bigger. So that is definitely.
I don't know. All the answers are pretty close, so to like the answer they gave, so I'm not really sure.
If we were to look at this line here, so actually it should be, this one should be 20. The distance from, if we were to take this line, so what would be this? If that's 45, that must be 45.
Yeah, and that's 90. So the other one's 45 as well.
So that's 90. And so what is this here?
2000 sine 45. No, cos 45.
Is it the square root of 2000?
Why would it be square root?
If that's 2000, and that's like Pythagoras, x squared plus x squared.
Oh, yeah.
So square root of 2000. But I get the feeling, is there no sine, nothing anymore? But it has to be times, yeah, 120, no, 20 times it. And that was sine. I don't know. I'll mess around with it and send you some shizzle. Let's see. This stuff, I just want to see what they look like. That one. So that was this is the very last one.
Okay.
Ooh.
I have no idea.
I'm just trying to see if the door is 4 meters long, but what is the door? What is not the door?
AB.
AB is the door?
Yeah. If you take moments around B, then that would just be 2,500 times
So
something.
this is similar to the drawbridge one,
Oh no. That's not gonna go well.
where that's halfway.
Yeah, that's weight, so it should be halfway. But there's like something sine 45, I think.
So the door is angled at 45 degrees.
Oh wait, no, it would just be 2. The perpendicular distance, wouldn't
So halfway,
it? Sine 45, I think.
so
Okay.
2000 sine 40, 2500 sine 45. I can't really see it. Anyway. Oh, taking moments about P. P?
Where's P? There's no P.
There is no P. Is this the right thing? F? 8? 8?
It says in order for the door to move, so
It must be the right
there's
one.
no P.
Anyway, I'm not sure what they're on about. Resultant moments.
Like half. Pretty confused. A bit confused.
Yeah, let's see. So if we go all the way back to where we started. So in general, magnitude of the force times perpendicular direction. So this is where it comes from. Those are okay. If it is clockwise, it is negative. You can add them together. These are okay. I think this one okay. I think
Like easy one's fine, but then
those are okay.
these
So
are not
this
okay.
one,
Wait, this one is okay.
you did, yeah. Just construct an equation in terms of x. This one, so we just kind of proved it, that it's just f sine theta is the perpendicular distance. This one was okay. So this is the one maybe we'll think about. Maybe I just did a minus sign wrong somewhere, but that's actually tan theta is greater than 2/3. I think I just put a minus sign wrong in there. So that one's actually okay.
This one's fine.
This one was fine. So this one.
This one's not fine.
So this is actually the only one then. The only
And
one.
like the one after, but we didn't really like do that properly. So.
I just don't see the door. I'll have to.
I don't see P.
Like, is this whole thing the aeroplane and these are the
I
wheels?
think it's A, like it's literally just A to B because it says the loading door AB.
So this tiny little thing down here is the door.
Yeah, but I don't know what P is. There's no P.
There is no P. I think it's, I don't know what they did. So this is the only one that's the thinker, 312. I'll look at that and see if I can come up with something.
Okay.
Yes, how is that for you, Amogha?
The first part was fine. The second part was like a bit confusing. But not like super bad.
Yeah. There's this one weird question. See, I don't like getting bogged down.
Is there more like moments?
Yes. So there's the second
half.
half.
There's like ladders and stuff. Yeah, I need to do that.
This type of stuff, equilibrium, where one side is equal to the other side.
Isn't there like ladders and things?
I'll just do a quick thing. Yeah, there's other stuff. Yeah, ladder against the wall, that type of stuff.
Yeah, I need to do this.
So we'll do that stuff next time?
Yeah.
Okay. Any questions for me in general? All right, well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good one. Goodbye.